All right, I think we're out there. Let's get this arranged. Switch that over to live. All right, I think we're good. Hey, we got some people watching. Good. All right. Oh, good. Even more people coming in. All right. What we're doing today is a variety of things. So there's several, and you probably hear the printer going. It's actually printing something for later on in class today. Hopefully it will. It looks like it'll be fine, even if if it doesn't finish, we can stop it in time, and the part that we need is actually on there. So we're talking about different ways you can join parts together once you've printed them. Most of this that we're going to talk about is PLA parts. Most of these things would work with the other FDM materials. Some of those materials may not work quite the same. You know, each one of these plastics is based on a different base polymer. And so some of them could have issues with adhesion with some of the glue type things. Some of these are mechanical, and so they'll work with whatever. But some of the glues, there are different types of glues. Some are like adhesive, where the glue itself is what holds stuff together, and others are they dissolve the plastic and remelt it together as a whole. And those kind of glues, which I actually don't use very often for 3D prints, they are specific to working with certain plastics. So I'll show some of the ones that you might run into. Like if you go to the store and look for glues, there might be these glues, and they're probably not going to work for the wider audience of plastics that you might want to glue together. So hope the printer's not too loud. If it is, let me know and I'll shut it down, because it does have enough printed that we could do what we need to do with it and let it go. Finish up printing the thing later, or never, it doesn't matter if we print it up or not. All right, so what we've got are a lot of different ways that you might joining pieces together after you've printed them. A lot of times you can't print the whole thing. It's too big, or it breaks and you need to repair it. I have a broken piece over here that we'll look at, maybe see it if we can repair. You might have moving articulated parts that you don't want to print in place. You could do that. You could just print them as a whole unit and then snap the pieces apart later to have it articulate. But sometimes you want them to or snap together or have joints after you've printed them. So that's another reason you might want to print things together, or put things together rather. So let's just start with the obvious stuff. So the most obvious thing that's going to work pretty well in most cases is just this. Where'd it go? Here it is. Just some sort of super glue. Most of the time, this is going to do what you want. Now, you're going to see a whole bunch of stuff back here. We'll get to that in a minute, because there are some downsides to super glue. Also, with super glue, a lot of times you'll have a kicker, a spray that you can spray on it, and super glue already cures pretty fast, but this will make it cure pretty much instantly. It might take a second or two to cure, but you can use this type of thing to really speed up curing. Maybe it's difficult to hold it in place or whatever, or you don't want to clamp it for very long or whatever it is. You can add a spray of the kicker and it will go off pretty quickly. These particular brands are just the ones that I can get locally, so there's nothing special about these, except that this is a thicker one. So you can see on there's a gap filling medium. I do tend to use the thicker super glues. They do make almost watery super glue type cyanoacrylate glues, and they can really get down in crevices and everything. Sometimes that's not so good with a print, because a lot of times if it gets past the wall or whatever, it's in the infill and there's actually nothing there for it to hold on to. And so I do use the thicker ones most of the time. This is a medium one. It's still pretty thick though. The downside to using one of these type of cyanoacrylate glues is that they can cure too fast. You know, you don't have a lot of positioning time. Even without the kicker, they can cure pretty fast. And so you don't have a lot of time to position things. And so that can be a downside. I would definitely recommend test fitting everything before you put the glue to it. The other thing is it's a little bit on the brittle side. Typically, not 100% of the time, but typically the faster a glue cures, the more brittle it's going to be. So the longer it takes to cure, you know, some of the epoxies take hours to cure, then the more robust the joint is going to be, the tougher it's going to be. And so generally, the faster things cure, the more brittle they're going to be. And super glue is at the pretty fast end of curing, particularly when you add the kicker to it. Then it's going to be a second or less for it to set up. And I'm using the word cure. Some of these do cure even past the point of they're holding. So it looks like they're dry, but they still could cure for quite a while after that. So maybe quite using cure correctly is a little bit different term, I suppose. But they set really fast. So something that sets really fast and it's pretty rigid is probably going to be kind of brittle. And so that can be a downside to using a super glue. But this is one of the things that you're going to do most of the time. You're just sticking something together, and it doesn't have to be particularly robust connection. You know, it doesn't need to flex a whole lot or have a lot of strain on it. Then probably super glue is the obvious thing to use. Some of the things that might look obvious but actually don't work very well are these. So these things, let's see what this, I think that's the samples I have right now. So all of these, so maybe you've built some plastic models before and you have this kind of stuff laying around. Most of the model, like you go to Hobby Lobby or somewhere and get a model kit and you build it, you know, the pre-made stuff, those plastics are styrene. And these glues usually are not an adhesive. They are the type that melt the plastic and reform it together. And so these are expecting to be applied to styrene or styrene base. Maybe they work with ABS because it has a styrene base in there, I think. But there's no styrene in PLA, so you can't count on these to bond PLA. So if you're printing PLA and you have this kind of stuff, you're probably not going to get a great bond. At least I never have. And they do make a type of glue like this for PLA. It's called Pla Goop, I believe. Let me see if they still make that. It's kind of expensive, and yeah, there it is. It is the same type of thing where it dissolves the PLA, softens it up to where it can bond with itself on the other side of the joint. And this stuff is one way you can do that. Let's see what the price is on it. Yeah, well, it's out of stock right now. So apparently it's supposed to be back in July 30th. $30 for, I can't tell. It's got maybe that's 115 grams or 11.5. I don't know. But for not a lot of it, so it's pretty expensive on the paying for 3D glue, the specific chemicals that dissolve PLA. Now they're kind of caustic. Let's see if I can see some of the warnings on here. Potentially harmful vapor. There's some delayed effects from long-term overexposure. Blah blah blah. So you know it's got several warnings that you don't want to be messy with this kind of stuff. But it does bond PLA very well. Now they're using it here for adhesion. So you're having adhesion issues on PLA, and this is a thing that you can apply to the bed of your printer and use that. But you can also use this for sticking PLA parts together. I did use some of this one time, and it does work. I don't know if there's a particular advantage for using it over some of the other things that I'll show you, except that it does bond chemically the PLA together. So it becomes one piece of PLA instead of two that you were gluing together, more or less. And here you can kind of see, a couple of seconds, half a minute of holding it together. So most glues in general of any sort work best if you clamp them for some amount of time while they're setting up. And then 80% strength after an hour, full strength in 6 hours. So that's kind of the curing part of it. So they do have this sort of thing. I don't know if I would use it very much just because of the price of it. So I would really need a specific application. And it does go bad. I had, or at least mine did. I had a sample of it for maybe, it was a couple of years. So it wasn't like it was brand new, but it did kind of go bad after a while. Or if you leave the lid off, it will basically dissolve, evaporate. So if you are thinking of using one of these type on PLA, probably not going to work very well. I suppose you could try it, and if you already had it, but I wouldn't go buy this kind of stuff because most of this sort of thing is made to melt styrene, which PLA is not. All right, let's get to some of those things that I had on the table here. Oh, well, no, here's another glue. There are the epoxies. They work pretty well, but they are specific to different plastics. Like this particular one, if you look on the little chart back here, and you look at hard plastics, which PLA would fit into there, this is, it works good, whatever that means, but it doesn't work great. To me, that's probably the marketing way of saying that, yeah, it's not going to work very well. Buy this other stuff, buy this Maxi Cure, which this is not the Maxi, this is the Quick Cure. And so, buy another one of these. And so you do have to make sure that you're using the right type of epoxy. And they do set up slower. This one's a 5-minute, but there are some that are in the hours of cure time for epoxies. They can be really good. They do need pressure to hold them while they actually do the curing part. So they're more of a lengthy process, but they add material so they can fill in gaps. It's pretty thick. You mix them up, you mix the two parts together. This particular one has 2 bottles. A lot of them have a syringe with 2 sides to it. This kind with the 2 bottles are, for me, a little bit easier to seal back up. You're typically not going to use the whole thing at once, and so you need to seal it up and store it. The ones with the syringe, they tend to never seal up for me. I guess I'm not good at that. But anyway, this kind of stuff can work. I don't use it that much. I think if I were using, trying to fill a really big area, a long gap or seam or something like that, that's when I would use something like this. For the smaller things, I don't think I would use epoxy. Maybe if I were repairing like a broken piece and I've got a lot of infill that I have to glue together and there's not a lot of material there because it's infill, and so I just have the walls and a little bit of sparse infill, I might use one of these because I could kind of force it into the infill almost as plugging the holes there. So I would probably use something like this, not this particular one in exactly, but a epoxy style to do that kind of repair work. So a big job. All right, let's see if I have any other glue things out there. I do, but I don't want to use them just yet. I made this, so it's just a little joint that we can glue together. So I think I made this in Tinkercad, just in a few minutes and printed it out. So some of the things you want to do when you're gluing in general is it usually helps if you don't have a smooth surface, or if you don't have a rough surface. If you do have a smooth surface on the parts that are going to glue together, it does help to rough that up a little bit. Now, there is a little bit of texture on a 3D printed surface already. In fact, you can kind of feel it when you rub them together, but I usually use some kind of file or whatever and just give it a little bit of grit to it. I'm not actually trying to smooth it. In fact, this may be too smooth. It's doing more smoothing than cutting. So you might get a file or whatever. Now, if you have an uneven surface, like I have blobs on here or something, then you probably do want to take those down so that you have maximum surface area when you go to glue. So if I were gluing these with super glue, super glue on here, clamp them down for 10 seconds, or well, whatever it says. Usually mine's covered up. So usually it's like 10 seconds. And then it's pretty much done. You can add the kicker to it to one side and the glue to the other side and hold it down, and that pretty much do it also. If you have a way to get the kicker to go down in the gap, then you can put the glue in there and then spray it on afterwards, and that'll set it off also. Other things you can do, maybe you don't want to or don't have all this stuff. You don't want to go get that. Because usually what happens when I buy one of these is I buy it and I use, a tiny bit, and then I don't get back to using it in a year or whatever, and the stuff has gone bad. So they're not the greatest investment unless you use them a lot. There are like homemade versions of that sort of thing. So two things you can use are baking soda and cornstarch. Let's see, what are the things you could use? Baby powder, talcum powder, same thing. Cornstarch, baking powder, all of those mixed with super glue. So these two things mixed together, they make a paste that you can 20 seconds maybe of work time, somewhere in that range. I don't know, I haven't timed it, but I'm guessing somewhere around 20 seconds of after you mix them together, you have a paste that you can put in a gap or whatever. These two mixed together, baking soda, not baking powder, but baking soda, and super glue, instantly make a rock solid gap filler. So I'll try both of those, one on this side, one on the other side. So what you can do is, let's see, let's do the baking soda first. So, got something that I can stir around with. Got some variety of tools here. So it's always good if you're doing this kind of stuff to have the cheap acid brush type thing that you can just throw away, or some sticks of various kinds. You can print stuff if you want to. But let's do this. Let's open this. I'm gonna have to open it where I can get down in there. So right now it's not open far enough. Okay. So we can do it one or two ways. We can put the baking soda in first and drop the glue on. That works better if the glue is thin. This is one of the thicker glues, so it's going to be a little bit not as flowy. So in this case, if I were doing this, I would probably want one of the thin super glues, drop the baking soda in, and then dribble the liquid, the really runny super glue on top of that. I don't know that I have one that I could find really easy. So I'm going to do it the other way, where I put the super glue in and the baking soda on top. So let's put it down in here. This stuff won't flow through the baking soda very well. So at this point I could spray the kicker on there and do it that way. Or I can do this kind of thing. Just kind of get it down in there. Let's see, I probably should have had a towel of some sort to clean this off. I'm going to put some on top of this. See, it doesn't flow. This is pretty thick, so it doesn't flow very well. In fact, it's kind of avoiding the baking powder. So let's use this one. Trying to get it to mix in there. The ones that flow better are better for this particular thing. Alright. I lost some from there. Let's add a little bit. There we go. All right, let me get a paper towel. I should have brought one. All right. Now, hopefully I didn't glue it to, yeah. Don't want to glue it to there. So you do get a little mess. The thing with this stuff is, if you do get it, I mean that I could probably snap it because, you know, the backside isn't glued, and I didn't actually glue in the gap here. But now I've got, like, I don't know if you can hear. This is what it, like, I'm doing this. It is like a little rock piece in there, and you can do sanding to it almost instantly. The baking soda really cures it quickly. I don't have a, this isn't very coarse. I need a coarser sanding stick to really start it out curing, or sanding. But that is a way that you can get in there really quickly and make a strong gap filling joint without, you know, some of this kind of stuff. All right, so let's do the other side with not this, but with the, I'm going to use cornstarch. Like I said, talcum powder, cornstarch, and the other thing I can't, oh, baking powder, not baking soda. They will mix together and they don't cure instantly. In fact, the three of them cure at slightly different rates. I think the cornstarch is the slowest of the three to cure. For this, I want to mix it up first. So I'm going to get some foil out if I can. So that I can mix it on there. All right, so the ratios do affect, you know, what's going to happen here. I'm going to do about 1 to 1, but not measure anything. Oh wait, not that. This cornstarch. Now cornstarch is super fine, powdery, so if you're not careful, it will go everywhere. All right, so I've already spilled a little bit of it. So there's our cornstarch. I don't know if I'll get 1 to 1 out of that, but it'll be all right. And we're just going to put some of our super glue. They do not mix immediately. I'm going to use, I'll use this one. You have to stir them around. You can start to see this little, looks like a little dough kind of thing here. So once you get to that stage, I'm not going to go too far, but once you get to that stage, now you've got, you know, a gap filling epoxy-like thing. And you can sand it at the end once it actually sets up, which is not long. It sets up pretty fast. But like I said, 20 seconds or so. I think I've lost all my glue at this point. And it's already starting to feel hardened. And you can fill in your gaps and glue at the same time with this pretty easily. And it sands, and you can paint over it and primer over it and all that kind of stuff. So you don't have to have the epoxy type stuff. You can get that same type of effect where you're filling in a gap and bonding with cornstarch, talcum powder, baking powder, all of those mixed with super glue. And again, the starch is about the slowest to cure. Let's see where we're at on our curing here. Yeah, still got some working time left. It's pretty thick at this point, but you could still work with that. I don't know which one is the next fastest. I think the baking powder would be the kind of medium speed, and then the talcum powder, baby powder stuff would be the fastest one, I think. But you still have seconds. You know, it's not instant. It's still 10 seconds or whatever to work with the others. If you put baking soda and super glue. Again, it works better with the thin super glue. That's instant. As soon as you drop it on the baking powder, the glue on the powder, baking soda, it's instant. And they both make these gap filling things, so you have more time to work with this one. Got it on my hands. But this one makes a really rock hard join right there. Both of them you can sand pretty well. I actually think a lot of times I end up with cleaner joints with the baking powder, cornstarch, the talcum powder. Those mix, the gooey mix here, end up with better joints with less work because you have more time to actually level them out before you have to. They're set, Basically, the baking soda super glue sets instantly. Let's see what we're at. Yeah, this one's starting to get. Yeah, it's pretty much solid now. So at this point, you could go in and do your sanding on it if you wanted to. So you can go in there and sand it up however you wanted to. And then paint over it or whatever your long-term plans are for that. So those are ways that you can create a joint, fill a gap, let's get it out of the way, and not have to go buy the epoxy that most of it's going to go to waste on. See if I can clean up our space here a little bit. All right, now we're back. All right, so those are the gluey type things. Sometimes you don't want to glue things though. Sometimes you want it to come apart, maybe. So if you glue it, then it's not going to come apart. And the best way probably is like metal hardware. So this works kind of across the board with any material, just because you're relying on traditional fasteners to work. So the fasteners, that's what we're printing, which is close to done. Let's do some of the print fasteners, and then the metal ones should be ready to go. So here you can have, this is not print in place. This one is, I printed them as two different parts and snapped them together, like this. Although it's really hard to get it apart. In fact, I'm not sure I can without breaking it. I'll try, and then I'll show you how I made it. Oh. All right, it did come apart. Now, I don't know if you'll be able to pick up on this, but these were printed in two different ways. So these were both printed, actually they were printed with the whole face down because there's a little rim inside there that I didn't want to have support around. So one was printed this way and one was printed this way. So the reason, this one had support on it. So the reason for printing them in two different directions is, first I wasn't sure if this one would survive because, the layer lines on this one are going across here, and these things have to pinch together in order to fit into the hole. And so I figured that it would just snap across one of the layer lines. Now it didn't. I've used it twice now, so like that. And it hasn't snapped yet. This one has a much looser fit also. This one should have the stronger ones because the filament is going lengthway here, so instead of shearing, it's bending when it has to pinch together. It's actually a much harder to do, and it doesn't quite have the tolerance that this one has. This one pretty much freely spins. And so the reason for that, this one's hard to get apart too, but not as hard. The reason for that is, since this is printed this way, the shape of the little clip is more accurate. Here, it's having to, it was printed sideways, this way, and so it had to create this clip as a series of layers, but they're actually circles, but they're flat lines on top of one another. Here, it drew them in circles, and so this one's a little more accurate. But it probably, long term, if you plan to snap and unsnap a lot, probably this one is gonna not last as long as this one. So how did I make these? So they were super easy. I've said before that I like to use Tinkercad. Actually, that's not the one I want to use. Neither is that. Let's just make a new one. And this is one of the reasons why I like using it, is because there's so many pre-built things that already work and are sort of intended for 3D printing in the end. And in your list over here of things, you've got connectors as one of your options. Now these connectors are ball joint connectors, pretty much all of them are. That's not exactly what I have here, but there are some snap fit ball joint type connectors and linkages and things like that, a little wheel even. But if we go to, I think it's shape library, and then go to hardware, there's all sorts of things, and there's the flexible snap fit, and there are others. There's a little spring type thing, some linkages, gears that will snap onto these. There's even a chain. What is in here? None of those I don't know. There's a shelf bracket, but there are things like this already made. And so all I did is I actually went to the basic shapes. In here there's a little dice shape. Took it out and went to shape library, hardware, took this out. Actually I took two of these. It has an option that lets it be either the pegs or the hole. And so for here, we just need to get this on top of here. So this is 16 millimeters tall. So just raise this up 16 millimeters. Slide it over, select them. Here's your align tool. Align them. And then, whoops, I don't want that one. Select them, Control G, or there's a group button up here. And there's the thing ready to go. And then I did the similar but opposite thing to make the hole. So in basic shapes, up here, basic shapes, got another one of the dice. Selected our little, don't want to deform it though. There we go. The options on this thing, I think I can't use them now. I think I have to do it right when I bring it in. So shape library, hardware, bring that in. Well, where are my options for it? You don't just turn it into a hole. I'm missing something. It has an option where you can select, like on one of these where maybe you're doing the let's see which one I know has the polygon. Where's it at? There he is. So the polygon, you can change the number of sides. This guy yesterday still had that as an option, but today it's not showing. So normally right here it would have the options to it's not locked. It would have the options for changing it into the other connector, but for some reason today that's not working. Not exactly sure why, but it should have the option to go in and turn this into a hole. Because you don't want to just turn it into a hole like this where they exactly match. That would not be what you want. See if we can see something over here in Tinkercad shapes. Oh, that's just going to send us to stuff people have made. Not what I wanted. Well, let's open the one that did work from yesterday, because it should still be in here. Nothing ever disappears. Here we go. So you can see what it looks like. I'm not sure why it is not doing that, but you give it the option. You drop that little guy in there. I wonder if I got it out of a different set of locations. Maybe I didn't use this version of it. I'll have to look and see if there's another version of it that shows up in another piece somewhere. I don't think it was in shape generators. It could be somewhere in there, but oh, maybe. Oh, it is. All right. So be careful with that. There are two versions of this thing. There's the one in shape generator, which lets you change it into the hole, either free spinning or a tight fit. I believe I did free spinning on these, and then you don't want to change these unless you change the matching peg. And so now you can have it, you know, on one of these sides. 16 millimeters tall. We got to turn it upside down though. Align it with this guy. Actually, we don't need to have it 16 millimeters from that point. Oh, we needed to align that before we had the other thing on there, because now they don't center the same. That looks right though. It's got one. I guess we need to snap it by 0.5 millimeter. Or less. Maybe it's even 0.25. Let's drop it down 0.1. That's probably good. And there you've got a little hole in there. So you can make these connectors attached to anything. You can even import your own STL file. There is a limit on file size, 25 megabytes. So there is a limit on how big of a file it can import, but you can import your own file and add these connectors to it from here. I did have one. That's what I printed. It just finished. Guess I closed it. Let's open it back up. This kind. So this one is not one that exists already in Tinkercad, but you can build ones like this where you've got a sort of cantilever spring that has a hook that will fit into a matching slot, you know, so you can have kind of a undoable one. This one does matter, the direction you print, at least this part. This one doesn't matter as much which direction you print it, except that it does have to print the roof. If you lay it down flat, it has to have to print one of these roofs with, you wouldn't want to have support in there. So it'd have to print it as a bridge. But this one does matter. So you want to lay this one flat on the bed so that when you flex this cantilever part, you're bending the filament strands instead of shearing them. So you would want it this way. And I did print that over here. So I printed them this way, I think. Got a little bit of unnice areas right in here where the hole is, because there's basically, I didn't leave very much material there. So it can slide in there, and this part will push in, and you can snap things together. It doesn't snap as well as I would like because of this area right here not being quite the right size. I tried to clean it up a little bit, but it just wouldn't clean up. But it does snap. So that's that kind of thing you can do. These snap really well and actually work pretty well too. And there were other connectors in there in Tinkercad that you can just add on to whatever geometry you have. You can make captured hinges. So I made this guy in SolidWorks. I didn't open SolidWorks. Let me go ahead and open SolidWorks so that by the time we are done with everything else, we can look at it. But here you can capture the hinge. Now you could drill a hole all the way through here. No, drill, I mean model a hole all the way through here and put a rod of some sort in like a traditional hinge, but you can also print them to where they print in place. There are a few things that you have to be aware of that I'll show once SolidWorks opens up. They'll be easier to show in SolidWorks. This guy is done. Let's get him off of our print bed. He's stuck really well. There it goes. So this one, now again, I printed this really fast. Well, fast compared to what I could have done. So it doesn't have many walls. But is this the right size for it? This might be the wrong size. There are these things. Let me get an assortment of them out. I may have got that hole the wrong size looking at my assortment of choices here. Some really tiny ones, some bigger ones, some, get them out, shorter ones, smaller diameter, and they come in all different. These are just the ones that I happen to have some of. So what these are metal inserts, so they're little brass inserts that if you print the right size hole, then these will go in there. Now this one obviously is too small. This one's definitely too small. This one may be too big, but we'll try to make it work. So the idea is you don't just push them in there, you actually heat them in there. So you have these kind of tools that will, one of these will fit, here it goes, fit this. And this tool can be attached to some soldering irons. The one that I have out right now doesn't actually hold this barrel. So I can't use this one, but I'll just use the soldering iron tip and it will go in here. So the idea is you heat this guy up and drop him in there, and it's a heat set threaded insert. I'm afraid this hole is a little bit too small though, but we'll give it a try anyway and see how it works. So I'm going to turn the soldering iron on pretty low. I don't want a lot of heat in this. It can easily melt this too fast. In fact, I'm not going to do it with this soldering iron, but if you have a cheaper, you know, one of the $10 just plug it in soldering irons, you can even use that to melt plastic together and have a mechanical bond by melting the two pieces of plastic to themselves. So I'm going to get this kind of in place and see if I can get it to go in there or not. I've got the temperature pretty low. Actually, I don't have it on. Let's turn it up to where it at least comes on. It was so low that it wasn't coming on. There, it's melting in there. It's super easy to overdo this though. In fact, I may need something to hold this with. The one thing that, again, I was printing this really fast, and so there are only 2 walls around here, so there really should be maybe 4, 5, or 6 walls around this thing, because you can already see it's melting all the way around here without actually going in. It is going in there now, though. Alright, so again, see, I kind of melted it everywhere because I don't have enough walls to support it. There's only 2 top layers, so if you're going to use that, you need all that plastic mass in order to actually do something with the heat other than just melt and deform. But still pretty hot. Now I've got actual metal threads in there. You can kind of see how it this hole was a little too small of diameter, and so I've got basically the hole is filled with plastic that was pushed out of there. So the hole, you do need to calibrate a little bit on the hole that you design compared to what actually gets printed. In general, and I didn't do this on this one now that I think about it, in general what you do is you measure the unknurled edge, or measure that, and then add another maybe 1/2 millimeter. Might be too much on something this size anyway, but on this size that would probably been good to add that other 1/2 millimeter, because it does need to be big enough that the knurls can start, not so big that they just fall through, and take into account the fact that your printer is probably printing the hole a little bit smaller than it is supposed to be printed based on your model. So there's a lot of balancing. What I would do if I were planning on using these much is just print a series of holes with, you know, different diameters. Figure out which one with your printer is the right size for your particular threaded inserts. This particular hole was too small, and so it kind of clogged up the middle and messed up our top surface. Also, do more than 2 walls around it. We did show in Cura how you could selectively apply a different infill or, you know, different properties around different parts of your model. That was a few videos back. That would also be a way to, maybe you don't want 4 walls on everything, but you just want a higher percentage of plastic right around the hole. You can do that too. So this is one way to get actual mechanical fastener in there. And now I've got metal threads, and it will pull out eventually, but it does, you know, if you apply too much force pulling it out, they will pull out. Too much torque and the knurls will strip out also. But it's actually much stronger than just trying to put the screw into the plastic itself. On the back side, now I'm noticing that this did not print correct shape, but you can print recesses to put actual hardware in there, you know, just like a nut or whatever. Now this one's not going to fit because it's deformed. I think I made this in Tinkercad, and I was doing it really quick, and I probably accidentally scaled that wrong because it's not, you know, not a regular hexagon. It's kind of squished, but you could get the regular hexagon shape and set these guys in there. Now the problem with this one is, other than the fact that it's the wrong shape, is that you're relying on the wall plastic to hold the torque. So something this size probably you won't have much problem with, because there's a lot of surface area to hold that torque when you go to tighten the bolt down. But the really tiny ones, you know, if you're using a really tiny nut, it's easy for it to round out and not hold. So that's a downside to using this kind of thing. You can also encapsulate these, so print up to here, drop the nut in, you know, like we did with the filament change, where you pause it and then let it finish over the top of it and actually encapsulate the thing. The downside to that is then it's inside the plastic and you don't have a way to get it back. You know, you don't have anything that you can do if it does fail. You have to take it apart. SolidWorks, I was looking at SolidWorks. It's almost ready, or it's loading up the part. You can also use screws. Now I've got an assortment here. Actually, those are the same thing. So one of these screws, oops, that one's off the screen, is actually a screw made for plastic, and it's this guy right here. So let's see if we can zoom in on their threads. Where are they at? Maybe one closer? Yeah, we'll get that. All right, so we've got some kind of wood screw here. Very aggressive threads, and you might get away with that if you had to. I wouldn't use it, but maybe that's what you have. This guy is a machine screw. Notice its threads are very, very tiny. This one, you know, you're going to use some kind of nut with the captured nut or the threaded insert, you know, that kind of thing. So they do serve a purpose, but you're not really going to be able to just put a hole in plastic and drill and screw this guy into it with this size anyway. Maybe this size, you know, it's a machine screw, but there is some thread to it there that could grip into the plastic. You probably could use this guy straight into the plastic hole without the threaded insert or anything like that, just a hole somewhere, and thread this guy in there. Don't model the threads into the plastic. You can technically do that. They almost never print well enough to do anything. It would be better just to use this and have it form its own threads as it enters the plastic. You can even heat these up, like over a candle or something, and then put them in there, and that little extra bit of heat will, instead of cutting the threads, it will form the threads. And so you can get away with these bigger ones. This little guy, there's just not enough thread there to ever hold anything really. This is just a coarse screw, like a sheet metal screw. It would probably be okay, but these, and let's see if we might have to zoom really far in to be able to tell the difference here. That's as far as I can go. Let's see if we can focus any better. Not really. But I think you can see. This guy, the one that's made for plastic, has a lot of thread sticking out compared to its root diameter. Where this one, the root diameter, now these are different size anyway, but the root diameter compared to the amount of thread sticking out is not the same ratio as a plastic screw. So you can get screws that are made for plastic, and these will, instead of forming threads like this guy would, so this one, if you heat it up and put it in there, it'll kind of form its way and make threads. This guy will cut its own threads in there, and it'll be pretty good. You can reuse it a couple of times before it fails. Now, if you over tighten or anything, it's really easy to strip the threads out of this kind of plastic. Any of these that you're going to try and use, you definitely need to have 4 walls or more in that spot at least where that screw is going to go. Let's see. There was one other thing I wanted to say about that. I'm trying to think of what it was. Let me look at my notes. Oh, I remember. You can. I don't do this very often in plastic, but you can use these things. If I can open them. So you can use a tap and die set. So I would use the more coarse ones. The larger, more coarse ones would be what I would use if I were going to try and cut threads into plastic. Go slow. If you go too fast, like if you hook this thing up to a drill and try to drill the threads through there, yeah, it'll do it, but it'll create too much heat, and it'll melt the plastic as you're cutting the threads, which will make you have not good threads. Plus, you got melted plastic on your taps and dies if you're using those. The die, like these guys for making external threads, I don't think I'd even try that. If you think about having to print a shaft of some sort that you're going to cut threads onto, I don't know that would ever be worth it. I've never tried it. I don't think it would work very well. But if you did, either one, you're going slow. At least this has a chance of kind of working. You just need to go slow so that you don't melt the plastic as you're cutting the threads in there. And use multiple walls around the hole so that you have plastic to remove. If you get into the infill, then that's useless for threads. So you can use these things, but now you're looking at you have to have a set of taps and dies, or at least the taps, or at least the one that you want. So it would give you a way. I don't think it would be the best way. The best way, if you're going to have something that's removable, is probably these guys. These are 30 or 50 cents each, depending on the size that you get. And so you can get a bag of them for a few dollars and have metal threads that you can definitely be assured that you're going to be able to attach whatever you're attaching multiple times before the threads fail. The threads probably won't fail. It'll be something else that fails. So those are some of the ways that you could go in and get some, snap fits, permanent threads. Maybe you can use the nuts and bolts type of thread. Let's look at the hinge. So I've got SolidWorks up finally. Let's get it to where it's fitting the screen right though. So here is a little thing I built, and so there's a couple of things that you need to think about. And this is not the only way to do this. This is just how I did it. But your little connecting point that is going to connect the whatever it is, box in this case, to the hinge. In this one, this side on the left of the screen, I just made it tangent here, so it's basically flat. There's nothing that needs to be supported. But this one can't be that way and still work the way I wanted it to do. I guess I could have made it tangent all the way across here, but instead what I did is I made these 45-degree chamfers because I know that my printer is able to print 45 degrees without needing any kind of support. So you don't want to have to use support on these things. That you certainly don't want support inside let's do a section here so we can, let's do this kind of section. Certainly don't want supports inside the location where the hinge is going to actually be. So what I've got is basically a dumbbell shaped part with a cylinder around it. That tolerance test that you did will sort of help with these, although the way I printed this was flat on the bed, and so it printed long ways here. So the tolerance test, most of the tolerance tests have you print perpendicular to that axis, so you have a tighter tolerance in that direction, just like we did on this one that was printed this way versus this one that's much tighter printed this way. I have more control over printing circles versus printing lines that make circles. So I did give it probably excessive. I think I gave it a 0.5 millimeter of clearance, and I think I might have given it, I don't remember, I think that might have been a 0.5 millimeter on each side. So there's a millimeter of clearance here, and you can see that it's very loose. In fact, it's probably too loose. I probably could have gotten away with much less clearance there. But I did want to print it on the bed this way so that that little bar has filament going this way instead of filament going this way, which would very easily shear if I do any kind of pulling. I can apply a decent amount of force without this coming apart, but if I had printed it where, like this, I would have better circles, but the shear planes right here would probably shear really easily. So I think I could have gotten away with much less, probably half the clearance that I actually gave it. So in other words, I could have had 0.25 millimeters on this side and 0.25 millimeters on this side and probably been fine. So you can do this sort of thing. It takes a little bit extra effort to figure out, how are you going to model all this to where it actually works. If it's a thing you're interested in, I would have a bunch of base models with the different types of connections and hinges and pins and all that you typically use, so that you can import those in and use them as almost as parts to build your bigger parts. Okay, I've got one other thing. Let me check my notes, make sure I didn't forget anything before we do this one. I guess I didn't specifically mention, and I've lost it now. Here it is. Designing parts in the first place, so that there's a lot of surface area on the glue joints would be a good thing to do if you're building the parts from the beginning. Make sure that you have enough gap in there. Now you can actually see I didn't clamp any of this, and that's what happens is you end up with some gaps in there because I didn't clamp any of it. I just dropped the stuff on there. You typically want to clamp things down better. It would have probably been good to glue this first, clamp it down, and then do this kind of stuff if I were really trying to, make this a joint with a nice clean edge on it. So designing the part to be glued in the first place would be useful. Two things left. One I can't really show, but I don't have a good way to show it, but I'll tell you it. Is that a Dremel with just a piece of filament. So here's some filament. So you can actually chuck up a little piece of filament, assuming you have a collet or a chuck for your Dremel high-speed rotary tool that's small enough. Chuck that into the Dremel, turn the Dremel on, and you can do sort of like a friction stir welding, but with plastic. In fact, back when I was little, there was a toy that was basically that. I think it was, I don't remember this. Spin Master. I'd have to look it up. Anyway, something like basically a really cheap Dremel that you could put plastic rods in and turn it on. They spin up, and you can use that to friction stir weld parts together. I don't do that very much, but instead, these little guys are pretty handy. So this is the Tech Boss Intelligent 3D Pen is this one. There are hundreds of these out there somewhere. In fact, I do have, let me see. I have the very first one. So this one is the very first one of these. I don't remember when that was. Well, first edition 3doodler.com. So this is the first one. They have advanced a bit. Basically, this is way smaller. What they do is there's a little heater in here, little motor back here. You can put some filament in it, turn it on. See if we can wake it up. Set it to PLA, or most of them do PLA and ABS. This one, I don't remember which all, or you can set it to different temperatures. So it might, if it can do ABS, it can probably do PETG also. And it's a handheld, I don't think you'd call it 3D printer, although you could kind of, it's 3D pen. In fact, the first one was called 3D Doodler, so 3Doodler, so 3D Doodler. And this thing, and they're not expensive. I don't know. I think you can get them in the $40 range even now. This one's got a little, they have a little plug in. I think there are some that are rechargeable too, so you don't even need the plug. I don't have one of those though. So I'm waiting for it to heat up. It's at 150. So it does get hot down here. In fact, this one came with some little fingertip glove type things so that you don't burn yourself. But you can use them, this kind of thing. All right, it's telling me that it's green. It still says it's pretty low temperature. I'm going to let it heat up a little bit more than that. It's at 160. It's what it says. I want to go up to at least 180. Okay, so I'm just modifying the temperature. It's at 170. And they all work slightly differently, but basically you've got some buttons for extrude and retract, and then some selecting type buttons over here, speed buttons. So I think silver is actually in here right now. So I've got blue here, but I think inside here is silver. So you can maybe hear it. That's this little motor running. It's pulling in filament. I'm waiting for it to come out the nozzle. There it goes. And you can use it to glue stuff together. You can also use it to make stuff, you know, with it as a tool, a pen type thing. That was the kind of the idea at first with these things, was that you could kind of draw in three-dimensional space and create your own structures and stuff like that. To me, and you can do that. In fact, on YouTube, there's some people that spend a whole lot of time with these things making really impressive stuff. But to me, what they're good for is you can use the same filament, or a contrasting one, to melt your stuff together. And now this is closed. I could peel it off of there. I don't think I can. So I think it is part of this box now. So I would have to sand it or scrape it off of there to undo that. So you can get super solid joints with something like this. Let's see how much they cost these days. Yeah, you can get them $60, $40. Well, $85. I don't have any of these expensive ones, but there's all sorts of them out there. Actually, this looks like the one I have. So it was a $40 one, but it's from Wish. I don't know. And this is an older one, so it's fine. It works fine. there probably have been some advancements. I don't know. There's definitely some more expensive ones. Actually, that's a foam cutter. That's a hot wire foam cutter. It's not the same thing. Some little starter kits. There's all kind of stuff like that. Oh wow! All right. Like I said, you can do a similar thing with a cheap. I wouldn't use one of your nice soldering iron, but one of those cheap ones that's just plugs into a wall with no control or anything. You can do the same type of thing, and you don't get filament coming out, but you can use it to drag and melt the filament that it does exist across there. You can even kind of do like stick welding, where you get your donor filament and melt it on there. You can do that sort of thing. That's if you have this though. This is so much easier, and they're not expensive. So they are a way that you can go and connect parts together. Usually you want to do on the inside, because you do end up with this, kind of seam on the outside that is probably not what you want, unless that's part of the aesthetic you're going for. I think that is all of the different types of connecting that I have. Let me check and see if I was going to write about or talk about anything else. Let me see if I can find. Oh, okay. It's the Mattel spin welder is, I don't want it to actually play. Mattel spin welder was the thing that I remember for the friction stir. All right, so next time, what we're gonna do is, oh, thanks. I'm glad it had. I mean, there's so many different things that you can do to glue stuff together, and it's a little bit too simple just to say use super glue and stick it together and apply some pressure. But that's, in most cases, that's probably good enough for putting plastic parts together. But there's a lot of little details about don't use the solvent-based glue that doesn't dissolve the plastic you're gluing together, and there's a lot of different stuff in there. What I have planned for next time is Octoprint. So what that is a remote control printer. So no more of having to go to your printer and get the little SD card. Where's that? There it is. Little SD card. Put it in your computer. Load a file. Stick it back in the printer. No more of that. That actually annoys me, particularly on the Ender 3, because of how difficult it is for me to get the SD card in there. So this will give us remote control over our Wi-Fi. Also monitoring. We can actually watch the prints on our phone or on our computer, as long as we're on the same network. So it's kind of risky. You can do it outside of your network on the internet, but then you're opening up your printer to the whole internet, and that's not generally the best idea unless you know what you're doing as far as security goes. But this does require some hardware that you may or may not have. So the hardware it requires is a Raspberry Pi. So we'll use, I think, probably a 3B, maybe a 3B plus. I'm not sure which one we'll use, but somewhere in that range. The little tiny Raspberry Pis, the Pi Zeros, they struggle to make Octoprint work well, and so I am going to use probably a 3B plus is probably the one that I have laying around that we can put Octoprint on. It's actually really easy to do. There is a little bit of setup that you have to go into some coding, but it's basically just put your Wi-Fi password and name into the software. And then now you can print remotely without having to do the SD card back and forth. You can check on your print without it being in the same room as you, that kind of stuff. So we'll do that next time. That should be actually Friday. Should be on Friday. And then it looks like we're moving into some modeling type stuff. So topology optimizations. Those are kind of cool topics. All right. I will see y'all on Friday.